So let us start understanding design of ordinary black bolts. So most of the case we will learn about the ordinary black bolts. Okay. So the type of bolted connection. So these are the type of bolt connection. See, first is bearing type bolt, which is also given in clause 10.3 in IS 800 2007. Next is friction type of bolt, which is also given in the clause 10.4 in IS 800 2007. So these are basically used to connect these two plates. So what are the types of joints? So the joint and connection is different thing. Connection is the thing with which you will connect or make connect two joints, and these are the types of joints where you can see the plates are aligned in such a way. These kind of joints of plate are called lap joint, and this type of joint are called butt joint. So I have a design of ordinary black bolt. So we have already discussed about all these things, because before designing with some structural element, you need to know what are the possible failures, or what could be the possible failure pattern that we have to categorize it. See what happens before examination. What we will do, we will go mostly prefer the subject which we are mostly weak in, right? So we need to know that in which part or in which case we are most weak or vulnerable. If we know that, if we know our weakness, then we can easily go and focus on that weakness, and we can prepare our designing as well. The same approach lies with our daily life as well. We need to know the strength, shearing strength of bolt, bearing strength of bolt, tensile strength of bolt, tensile strength of plate, combined shear and tension. So these five parameters are the possible weakness or the possible failure parameters where a joint or where a connection can break or collapse. So we need to focus on these things while designing a connection with a bolts. Okay, so let us get aware with some some safety factor notations. See, this is called gamma f. So I am just showing partial safety factor for load. Okay, gamma m represents partial safety factor for material. So for loading purpose, the safety factor terminology is termed as F, and for material safety factor it will be M. Okay, next is gamma M0 or M naught. This can also, you can say, partial safety factor against yield stress and buckling. So this yield stress and buckling partial safety factor will be designated with this MO. Next is M naught, next is M1. So M1, this is representing the partial safety factor against ultimate stresses. So representing ultimate stresses, it will be M1. MB will be partial safety factor for bolted connection with bearing type bolts. Okay. Next is gamma MF. MF represents the partial safety factor for bolted connection with high strength friction grief bolts. Okay, so these are some corresponding safety factor you need to remember. Okay, well, come to the part of design of ordinary black bolt. First is bolts in shear. We will study about. See, the formula is given. You don't need to just memorize it. Just go through the concept. Everything is given in the IS code, but you need to know why such formulation has occurred. You need to know the basics, right? So the bolts in shear is represented as VNSB. This is actually given in clause 10.3. Just let me get. Okay. See, in 10.3, bearing type of bolts, page number 74, it has started. So here, see, shear cap in 10.3.3, the shear capacity of bolt is given. Here, VNSB. Let's come first at VNSB, not VDSB. Let first come at VNSB. So what is VNSB? Can you able to see that clearly?
Yes, ma'am.
Okay, okay. So VNSB is represented as nominal shear capacity of bolt. So here we are judging the bolt as per its shear capacity by this formula. Okay, so let us see what in this formula is given. It is given Fu divided by root over 3 into NB plus NS into ASB. Well, what is FUC? We all know that this is a force, right? VNSB, this is a shear force. So what is force? Force, we know stress is equal to P by A, right? Load per unit area is designated as stress, but this, see in this formula, this is given as a force terminology. So in order to get the force terminology, we need to multiply that area with stress. See this, so that Fu must be stress and this A is area. So stress into area is giving me the force, and these are some corresponding coefficient which we need to observe depending upon the connection system. Okay, so see here, I am just neglecting this part. Okay, this is the actual formula we need to observe on. See, FUB, this is represented as FUB. FUB is nothing but the ultimate tensile strength of bolt. So, well, in order to know or judge the shear's force capacity of a bolt, you need to know the shear's ultimate tensile strength of bolts. Okay, see if the picture is given, well, see what happens. This is the bolt head and this is the shank part and this will be the threaded part, right? So these things will lie in between the plates. Connecting a plate, it will lie something in this manner, right? So when a force will be applied in this axial way, we need to know the ultimate tensile strength of this bolt, and root divided multiplication as 1 by root 3. This NN is representing number of shear planes with threads intercepting the plane. Well, let me show you similar way in the code is given. Number of shear planes with threads intercepting the shear plane. Well, what is shear plane? Shear plane is, let me show you a picture here. See, just look at this diagram. This is a bolt and the plate will be aligned in such a manner. So the planes are these. Okay, these are the planes. So invading or this plane will be injected by this beam, this bolt in order to connect this joint, right? So these will be the planes corresponding shear planes. So now we have to observe how many planes are this bolt. This is the shank part, right? And this is the threaded part. So how many planes are these part are invading or intercepting or if have been injected, right? How many layers or shear planes are lying in between these shank part? We need to identify that, because see what happens when this will be subjected to a certain amount of force. See, just observe this part, only this part, only this part. Okay, just observe This part of the bolt will be the maximum to take that shear force effect crossing through this, I mean, occurring due to these plates, right? So we need to observe that. See, here it is given number of shear planes with threads intersecting. See, thread part is this part. This is the thread part where the knot can be uh, adjusted. Okay, so how many threaded part is lying in between the shear planes, that will be designated as NN. It may be one plane, it may be two plane, it may be three plane. It will depend upon the number of plate we will tend to connect, right? So that will be designated as NN. Next, see, this is A N B. What does A and B represents? It says that net tensile area of bolt to be considered at the root of the threads. See, root of the threads mean net tensile area. See, net tensile area is net and gross. You need to differentiate in between these two terminology. Gross will be always all total. Say you are hired to a company, okay, so you are getting a salary of gross salary of say 15,000, say 15,000 gross salary, but monthly in hand you are getting 13,500, and the rest of 1,500 getting deposited in PF account or some another account. So that 13,500 rate will be your net amount which you are getting in hand, and the gross salary will be which is adjusted to your PF account. It you will achieve it in later in future. So that accumulating that price with your net amount will always show you the gross. Okay, so here also the same concept lies. See, the net tensile area mean the reduced tensile area, mean what are we actually considering while designing a or while considering a strength of bolt. See, net tensile area of bolt to be considered at root of the thread. See here why this net and gross scenario is coming. See, here this part I am just showing you in different in this place. See, this is the total shank part, right? But here a threaded part is getting started. So what happens, due to that threaded part, some amount of area is getting reduced, isn't it? In that threaded part, some amount of area is getting reduced from the shank part. So the area is getting reduced when a plate lies in this threaded part, when stress is equal to P by A. So when the area will be reduced, the force will be increased, the stress will be increased, right? So when a see what happens, a same amount of force taken by this plane part will be some amount, but that same force, when it will go through this plate, the stress will be increased. Why? Because the area have been decreased in this threaded part. So the decreased part of area will be considered as the net area. Okay, this is the net area. So A and B is represented as net tensile area of bolt to be considered at the root of the threads. This is considered as C. We know how to calculate the circular area. Pi into d square by 4 into C, 0.78, mean almost 78 divided by 100. This can we can represent, mean out of 100% of area, we are only considering 78% of area, multiplying with area. Here the diameter will be given. If see this plane diameter, if that diameter is given to be 20 millimeter, then that net area will be 0.78 into pi into 20 square divided by 4 equal to some amount of area millimeter square. That will be your A and B. Okay, next is NS. NS representing the number of shear planes without threads intercepting the plane. So here, see how many planes are lying without the thread part? Only one. So that will be ns will be only one for in this case for this diagram. So in this way we will measure this in ns. Okay, and n and ASB is nominal plane shank area of bolt. So this will be only pi into d square by 4. There will be no reduction with the percentage. So I will come to these factors later on. So this is for the reduction factor. See in this code, this is given. This is for the long joint category. So when I will discuss about the long joint problem, I will go through these descriptions. Okay. So now, for now, I am not going through this. So this is our actual part of understanding. See, NN was representing our number of shear planes with thread and ANB. See, this is multiplied with ANB. ANB was the net tensile area in the threaded part, and NN was the plate lying in between the threaded part, which is NN into ANB plus NS what was the shear plane lying in between this pure shank part into ASB was our the shank area. So that will be accumulated into that area will be accumulated into the ultimate tensile stress of bolt divided by root over 3 will give me the nominal shear capacity. Will give me the nominal shear capacity. So now this is the nominal shear capacity of a bolt. Now we will consider the design strength. Now this will be the nominal and this will be the design strength value. See, this is represented as VDSB. VDSB is equal to nominal shear capacity divided by gamma MB. So gamma MB is represented as what I have mentioned here. This is the partial safety factor for bolted connection with bearing type bolts. So in this category, actually it is a bearing type of phenomenon occurring. So in the place of shear judging the shear capacity. Okay. So now, so you must be that okay. So why are we calculating these two types of shear force? Why we are just creating these two separate type of shear force, analyzing VNSB and VDSB? We have also understood that N representing nominal, D representing design. But why? What is the purpose of just separating these two shear force terminology? Well, okay, let me just give you one example for it in here. See what happens in the time of designing. There will be a strength shear capacity of a bolt itself, right? Say a bolt has a capacity. Okay, so let me take another example, another very easy example. In these days, just a minute. Okay. In these days, in COVID situations, what is happening? We are collecting or we are accumulating all the groceries of our household in our daily life, right? So what is happening? For monthly deposition of your grocery, for one family, you might need 10 kilo of rice. Okay, right? For 10 kilo of rice, you might need for 1 month of deposition. But what happens? What your parents does is they take a margin of 10, not 10 kilo, they take a margin of almost 12 kilo or 13 kilo. They always take a safe side, right? तुम जब बाजार में कुछ खरीदने जाते हो पूरा मंथली बाजार करने के लिए, तुमको अगर मंथ में 10 किलो का राइस लगता है तो तुम 10 किलो नहीं थोड़ा और ज्यादा खरीद के ले आते हो घर में. It might be 2 kilo or 3 kilo extra. So that why you are taking that extra thing? Just to be assured, to be in a safe side. ताकि लॉकडाउन अगर फिर से बढ़ गया, तुमको तो पता नहीं, अगर किसी भी तरीके से राइस खरीदने को नहीं मिला तब क्या करोगे? इन दैट सिचुएशन वी टेक दैट सेफ्टी मेजरमेंट. सो व्हाट हैपेंस, सी यहाँ पे नॉमिनल शियर फोर्स से एक बोल्ट का कैपेसिटी आता है 5 किलो न्यूटन से 5 किलो न्यूटन आता है. ये एक एब्रप्ट वैल्यू में ले रही, पर मैं क्या ये 5 किलो न्यूटन फोर्स लेके काम करना ये सेफ रहेगा? मैं क्या करूंगी, थोड़ा इसको घटा लूंगी बाय डिवाइडिंग विथ सम पार्शियल सेफ्टी फैक्टर. तो घटाने के बाद शायद मुझे 4 किलो न्यूटन मिलेगा, मे बी 4 किलो न्यूटन होगा. तो अगर मैं थोड़ा कम फोर्स कैपेसिटी लेके डिजाइन करूंगी तो फिर इसमें अगर डिजाइन बच जाता है, इतना कम फोर्स इतना कम कैपेसिटी लेके अगर कोई जॉइंट बच जाएगा तो इतना ज्यादा कैपेसिटी में तो बच ही जाएगा ना. एक सेफ साइड के लिए इसको हम रिड्यूस करेंगे बाय डिवाइडिंग विथ सम पार्शियल सेफ्टी फैक्टर. Okay, that is why these two types of VBSB, design strength and nominal shear capacity, has been considered in IS code. Okay, clear? Well, next is this I have already explained, and this partial safety factor value has been given in the IS code. I will show you that in later. Just let me. I have to search it because I have forgot the factor of materials are given in here. Okay, from this we can collect our data of partial safety factor. So this is again for long joint. I am not discussing it right now. Next, we have discussed about bolts in shear. Now we will discuss about the bolts in bearing. The bolts in bearing. Bolts can fail in bear as well, as we have studied in our previous failure types in the connection. So see here. Right. Right. See, here a bearing capacity of the bolt is given. The design bearing strength of a bolt on any plate is considered to be VDPB. So again here a design strength we have to consider for our safety purpose, which will be again divided by some partial safety factor, and VNPB will be our nominal bearing strength of bolt. Sorry. This is represented as, see, 2.5 into kV into D into T into FU. So again this is a force formula. So force formula will be represented by stress into area. So here we are getting stress from FU, area from D into T, and this is the external factor. So why we are considering here D into T, and why we have considered in the place of shear capacity A, which was the circle area. Why we have considered this circle area in the place of considering the shear in bold? Because see, each and every plane, each and every plane, if a plane get failed, then how that bolt will look? That bolt might look in this way, right? That bolt may fail in this manner. So what is happening here? See, a circumference of a bolt is directly getting influenced by this shear plane of the plates. That is why we were considering the area of this bolt, circular area of the bolt. But in the case of bearing, we are considering the area as d into t. D means that dimension of the bolt, and t mean, see, t mean that dimension of the bolt, and t is the thickness of the plate. So this is the area we will be considering while judging the bolts in bearing. That is why we have considered d into t. See here, d into t is nominal diameter of bolt, and t is the summation of the thickness of connected plates experiencing bearing stress in the same direction, or if the bolts are countersunk, the thickness of the plate minus one half the depth of countersinking. So this is some brief expression given here. While solving a problem, I will come to this explanation to you. Okay, so that will be initially, that will be the summation of the thickness of the connected plates. Okay, that will be our T, experiencing bearing stress. So here P into T is representing that, and Fu is our ultimate tensile strength. FUB B is representing for ultimate tensile strength for bolt, and only U is representing for plate, stress for plate. Now come to this factor 2.5 into KB. See here 2.5 with this formula here, and KB is representing with the several factors. See, KB is a smaller. We will consider the smaller of these four values. This is 1, this is 2, this is 3, this is 4. 1 is representing the E by 3 D naught. What is E? E is the end distance of the fastener along the bearing direction. I have shown you what is end direction. This is the end distance of a holding connection. Remember? So this will be our E value. Next, D naught is our diameter of hole. So that end distance divided by 3 into diameter of hole, we will get a value. Next, P divided by 3D naught. P is representing the pitch distance. What was pitch distance? Pitch distance our this distance. The distance which will lie parallel to the force, the direction of the force coming to the joints. Okay. So this will be our pitch distance of the fastener along the bearing direction. Minus 0.25. That will be reduced by 0.25. Now we will get a value from this as well. Next, FUB by FU mean the ultimate tensile strength of bolt divided by the ultimate tensile stress of plate, comma 1. So the smaller among these four formula, we will consider the value of KB. So that 2.5 into KB into D into TFU will give me the nominal bearing strength of bolt. Now that bearing strength of bolt will be divided by a partial safety factor, giving me a design value. So reducing its actual capability with a partial safety factor, we are considering a bolt to be quite weaker than its actual capacity. So if that connection get passed with its weaker bolt capacity, it will definitely get passed in its higher capacity. Okay, so that is the purpose of adjoining this design factor. Okay. Now let us see, this is the failure pattern which I have shown. This is the bearing failure pattern. See, in bearing failure pattern, what is happening? This part is getting stretched, isn't it? So this part is contributing of how much of area? The D of the D is the whole diameter and T is the thickness of the plate. So D into T part is getting affected in the time of bearing failure. Similarly, for shear failure, see, this total portion is getting cut out. So that is why we are considering the total area of the bolt which has been punched through this plate. Okay. Next type of this is the bolt failure pattern which I have shown. Next is the tension. So these are the very weak subjects for bolt. मतलब बोल्ट ये टेंशन शियर बियरिंग इन तीनों सब्जेक्ट में बहुत पुअर है, बहुत वीक है, तो इनको हमें इसके तरह प्रिपेयर करना है। जो जिस सब्जेक्ट में वीक है हम लोग उसमें ज्यादा फोकस करवाते हैं ना। तो अब नेक्स्ट आता है टेंशन में। सी इन टेंशन see, in tension, the formula is represented as here TNB, first TNB, which is nominal tensile capacity of the bolt, which is calculated as 0.9. Mean we are considering only 90%, we are not considering 100% as stress of bolt into AN. What is AN? AN is the net tensile stress area as specified in the appropriate IS code for bolts where the tensile stress area is not defined. AN shall be taken as the area at the bottom of the threads. Okay. So it has given specified the area of the bottom of the threads, and ASB will be the shank area here. See here AN we will take. So for in the case of while we are considering the thread part area, see we are reducing 90% of the bolt's ultimate tensile strength. So that must be less than the yield stress of bolt into ASB. ASB means the actual shank area. So this is the part of ASB. Okay, the actual area into gamma MB means the gamma MB by M naught. So MB by M naught, what we have studied here, sorry. See, MB is the bolted connection with bearing types of bolts, and M naught was partial safety factor against yield stress and buckling. So that we have to. Did I lost the page? Just a minute. See, this is a failure at tension. See how this is getting failed in tension. So tension, what does tension mean? If you pull a elastic girder, say this is an elastic girder, you are pulling from this way. So it will try to get elongate in this direction and in this direction as well. So the failure will also occur in this direction. See, in a similar way, a bolt is getting failed in this direction in the case of tension. So in the case of tension, the failure may occur at that location of the bolt, or the failure may occur by cutting all the thread, that extended part of thread, and that total nut can come out from this bolt. Okay, so today up to this, let this lecture be lie up to this. Let me call your name one by one, then you can leave. Okay, just tell me now, have you understood up to this the shear capacity of bolt, bearing capacity?